Depression affects more than 150 million people worldwide, making it a leading cause of losing healthy years of life as a result of disability. In fact, by 2020, depression may be the second leading cause of healthy years of life lost, second only to heart disease. Why is depression so common? Well, it is said nothing in biology makes sense except in the light of evolution. But why would we evolve to get depressed? Depression poses a baffling evolutionary puzzle, if it has such negative effects, but yet it remains so common and heritable, meaning a big chunk of risk is passed through our genes. So there must be some kind of adaptive benefit. Otherwise, presumably, it would have been naturally selected against. Maybe depression is an evolutionary strategy for defense against infection. Infection has been the leading cause of mortality throughout human history. The average life expectancy was 25, and it was not uncommon for half our kids to die. With such stark capabilities, infection has been a critical and potent driving force in natural selection. When we become infected, there's a surge of inflammation as our body mounts a counterattack. And then what happens? We feel lousy. We feel sick, we get weak, tired, slow, and sleepy. We don't want to see anyone, we don't want to do anything. All we want to do is sleep. It's like we're depressed. And that's great for fighting infection. Not only does it help us conserve energy so we can put up a good fight, but reduces social contact. We're not running around infecting everyone. It's the same reason we evolved to think poop doesn't smell good, or decaying flesh. That keeps us safe from infection. In fact, we see this phenomenon with other social animals like honeybees and mole rats, who feel impelled to crawl off and die alone when they get sick, which reduces the risk for the rest of the community. The relationship between mental health and inflammation was first noted in 1887, for which the only psychiatrist ever win the award got a Nobel Prize. But what evidence have we accumulated in the centuries since that inflammation causes depression? Well, people who are depressed have raised inflammatory markers such as C-reactive protein. Inflammatory illnesses are associated with greater rates of major depression. Indeed, that's what's found in a variety of inflammatory conditions, including more kind of benign inflammatory conditions like asthma and allergies. And that's important, suggesting the mood symptoms are not simply feeling bad about having a terrible disease, but may be directly tied to the inflammation. And most powerfully, you can actually induce depression by inducing inflammation. Like when we give interferon for certain cancers or chronic infections, up to 50% go on to suffer major depression. Even just giving a vaccine can cause enough inflammation to trigger depressive symptoms. Taken together, these studies are strongly suggestive of inflammation being a causative factor of mood symptoms. So, can an anti-inflammatory diet help prevent depression? We didn't know until about 43,000 women without depression were followed, along with their diets, for about a dozen years to see who became depressed. And it was those who ate a more inflammatory diet pattern, characterized by more soda, refined grains, and meat, suggesting that chronic inflammation may underlie the association between diet and depression. Normally, we think of omega-3s as anti-inflammatory, but they found fish to be pro-inflammatory, associated with increased C-reactive protein levels, consistent with recent findings that omega-3s don't seem to help with either depression or inflammation. The most anti-inflammatory diet is plant-based, which can cut C-reactive protein levels by 30% within 2 weeks, perhaps because of the anti-inflammatory properties of antioxidants. I've talked about this before, but never really explained why antioxidants are anti-inflammatory. See, oxidative damage caused by free radicals may cause an autoimmune response in the body by changing the chemical structure of otherwise ubiquitous molecules to generate new structures that the body attacks as foreign. For example, when LDL cholesterol gets oxidized, our body creates antibodies against it and attacks it. And so clinical depression can be accompanied by increased oxidative stress and the autoimmune inflammatory response it creates. Free radicals lead to autoimmune inflammation. Where else does inflammation come from in our diet? Endotoxins. Right? It's worth reviewing how the endotoxins in animal products can cause a burst of inflammation within hours of consumption. What does it do to our mood? If you inject endotoxin into people, within a few hours, inflammation shoots up, and so does feelings of depression, as well as feelings of social disconnection between people. Although previous research has demonstrated that inflammatory activity contributes to depressive symptoms, no work in humans has examined the effect of experimentally induced inflammation on anhedonia, the lack of reaction to pleasurable stimuli. This is an important symptom of depression. No work has been done, that is, until now. Within hours of endotoxin hitting their bloodstream, these experimental subjects not only started to feel depressed, but they had significant reductions in activity in the reward center of their brain. They were less excited about winning money playing video games, for example, in this study. But by eliminating animal products and eating antioxidant-rich diets, we may be able to prevent or treat depression.
In this video, I'm going to talk about the biological basis of depression. And I'm not talking about just a passing bad mood, but I'm talking about major depressive disorder. Major depressive disorder is a major cause of distress, disability, and death from suicide. It is the prototype of the category of mental illnesses called the depressive disorders, which involve distress or disability from abnormally negative mood. In addition to negative mood, the depressive disorders often involve related symptoms, such as feelings of hopelessness or loss of enjoyment in activities. As of 2014, when I'm making this video, our understanding of the cause of major depressive disorder is still very limited. When we look at the brains of patients that have major depressive disorder, either with the naked eye or with traditional microscope studies, there are basically no consistent abnormalities that have been seen in the tissues of these patients. However, special scans and research involving animal models have suggested that there are some functional abnormalities that can be detected in the brains of many patients with major depressive disorder. So here in this illustration of the brain, we're looking at the outside of the brain, and the different lobes of the cerebrum, the top part of the brain, have been labeled with different colors. And in this illustration, we're also looking at the brain, but it's been divided into right and left halves, and we're looking at the inside of, in this case, the left half of the brain. And a couple of specific areas that have seemed to have abnormal activity in these studies involve this part of the brain in this light blue color, which is called the frontal lobe. Let me just write that. Frontal lobe, the lobe that's most toward the front of the brain. And over here on the inside, that would be all of this stuff. All of this stuff right here is also the frontal lobe. And the other part can't be seen on the outside, it can only be seen on this inside view. It involves a number of different structures, like this structure here, and some others that are behind the brainstem over here, that are called the limbic structures. Let me just write that word down, the limbic structures. Limbic structures, right here. And these studies have suggested that there appears to be abnormally decreased activity in areas of the frontal lobe and areas of increased activity in areas of the limbic structures. These findings seem to fit well with other studies showing a role for these parts of the brain in regulation of the emotions, and in particular, responses to stress. Functions of the brain that seem to be particularly abnormal in patients with major depressive disorder. In regards to stress, it's also been noted that many patients with major depressive disorder have abnormal blood concentrations of certain hormones that are particularly associated with stress. For example, the hormone cortisol, that's a major stress hormone. There's a particular area of the brain that controls most hormones, including the stress hormones, that's located right here. And this area is called the hypothalamus. Hypothalamus. And the hypothalamus talks back and forth to many areas of the brain, but two areas in particular that it communicates with back and forth are the frontal lobes and the limbic structures of the brain. So it's thought that perhaps abnormal communication between the frontal lobes and the limbic structures and the hypothalamus in major depressive disorder play a role in why there are these abnormal concentrations of certain hormones related to stress in the bloodstream of these patients. These stress hormones may affect most tissues of the body, but they also affect the brain itself, including the frontal lobes, the limbic structures, and the hypothalamus that actually controls their amounts in the blood in the first place. So for major depressive disorder, it's still unclear which abnormalities of these stress hormones are causes and which are effects of the disease itself. Some features of major depressive disorder also appear to involve abnormalities in neuronal pathways using certain neurotransmitters, the molecules that communicate between neurons in the brain. And the abnormalities of these pathways may cause abnormally decreased or increased activity in certain parts of the brain, like the frontal lobes and the limbic structures. Collections of many of these neurons that produce these neurotransmitters have their somas, or their cell bodies, in a few areas of the brainstem, this structure below the cerebrum, and then their axons project to many areas up in the cerebrum, including the frontal lobes and the limbic structures. One of these pathways start in what are called the raphe nuclei of the brainstem. And there are several groups of raphe nuclei at different levels of the brainstem that send projections up to many areas of the cerebrum, including the limbic structures and the frontal lobe. And they're responsible for much of the serotonin that's secreted in the brain. Serotonin, which appears to be abnormal in many patients with major depressive disorder. Another pathway starts in an area called the locus coeruleus. Which is located right around here in the brainstem, and it also sends long axons up to different areas of the cerebrum and releases a lot of the neurotransmitter called norepinephrine. Norepinephrine. And this also appears to be abnormal in many patients with major depressive disorder. Then there's a pathway that starts with an area called the ventral tegmental area, which I'll just write as VTA for short, which is located around here in the brainstem, and which also sends long axons up to different areas of the cerebrum. And the ventral tegmental area supplies much of the dopamine to the brain. Dopamine. These neurotransmitter systems affect the function in many parts of the brain, including the frontal lobes and the limbic structures, and supporting the idea that abnormalities of these systems are involved in major depressive disorder is the fact that medications that affect these different neurotransmitters, dopamine, norepinephrine, and serotonin, often improve the symptoms of major depressive disorder. A newer idea that is interesting is that there may be abnormalities of what is called neuroplasticity. Neuroplasticity, which is a big word that just means that the brain changes in response to experience. And these changes may occur down at the level of a connection between a couple of brain cells, a couple of neurons in the brain, where the strength or efficiency of information flow from one neuron to the next may change based on experience. Or it may happen at the level of networks of neurons that are widespread, different kinds of connections and pathways that information is flowing through the brain based on the experiences that the brain is having. And evidence is accumulating that aspects of neuroplasticity appear to be abnormal in animal models of major depressive disorder. But like the other abnormalities that have been found so far, it's unclear if these abnormalities